Okay, so we're going to do a larger example now of inheritance and also polymorphism. And what we're going to do is we're going to create this class hierarchy of staff members. And we did the staff member class in a previous video. But for this, we're also going to introduce how to do header files in C++, which is essentially the same as with C. So here's my original staff member file, and I'm going to create a header file. So I'll save a copy of this file as the header file, StaffMember.hpp. And once I do that header file, I can include that in the CPP file. So there's my header file, and I'll delete the class declaration, but I'll leave the print function. I also don't want anything to do with the main function here because that can create problems down the road. So I just have my print function. I also think probably I can get rid of this using namespace standard here because there's few enough of these that I think I prefer to not do that in libraries anywhere, even though in this case it would be fine. One other thing is I'm going to make this function const, and that's just to indicate to anybody using it that this function is not going to change the value of the staff member object. So now let's edit our staff member header file. So we don't need any of these functions defined anymore, but we do want to keep the class definition, and we definitely want to get rid of the include statement and the namespace statement. You don't want to force any using namespace calls on anybody including this file, and you also don't want to include any files that aren't necessary because you're just creating garbage in the file that includes this. So unless you need that include for some reason, you can avoid having that here. So in this case, this is going to eventually be our base class. I think all this is good. We need to make sure we put standard in front of all the strings. Again, we don't want to use using namespace standard here because that can definitely create issues down the road. We're going to use an initializer list here. We have a print, and then we're also going to add a pay method. That'll be a virtual method because we're going to want all of our child classes to implement this method. Okay, so that's our staff member. So now let's take a look at some of our derived classes that we're going to derive from staff member. So the first thing is we're going to have another class of employees under staff member, and that's going to be for actual full employees. So we're going to include StaffMember.hpp just so that we can pull in that class because we're going to, in our employee class, we're going to extend staff member. And the employee class is going to have a social security number. And we're also going to have a protected member for the pay rate. And the reason is this is still going to be an abstract class. We're not going to instantiate employee objects. We're going to have different classes of employee, and those will be based on how they're paid. So the pay rate is going to be different for each class of employee and how that's used. So we're going to allow the derived classes to modify that value. And then our constructor is going to be public. There'll be a string for the name, a string for the address, a string for their phone number, a string for their social security number, and an int for their pay rate. We can initialize this with staff member by calling the base class constructor within A and P, the name, address, and phone, and then use initializers for the social security number and the pay rate. And once we do that, we don't actually need anything in the body of our function. So I don't think we're going to need any additional functions here because this is going to be an abstract method. So I don't think we need to do any declarations. We'll just get all of those from staff member for the derived classes from employee. I am going to go ahead and do a print method here. And the reason for that is I think we can print most of the employee's information based off of this. So let's go ahead and say we're going to have a void print, and that's a constant function method because we're not going to make any changes there. So I'll save that. Let me go ahead and create the C file for this. So in my employee header file, I'm going to include Employee.hpp, and I'm going to define my print function. I'm going to use the scope resolution operator to indicate that this is the print method for the employee. It's a const function, or a const method, I should say. And I'm going to call staff members print function to print the name, address, and phone number. And then I'll print out their social security number, and I'll also print out their pay rate. And in the C file, I'll say using namespace standard. And that should be good for my C file. I'm going to go ahead and compile just to make sure I'm not creating too many syntax errors here. Okay, so there's one. And then it looks like, let me take a look at staff member. So that's constant. That's constant. So, oh, no, it's not. Keep in mind that const is part of the method signature. So those were two different methods I was creating there. So employee.c++. Yeah, so I'm not sure why that's. I didn't include IOStream there. And it looks like that takes care of all of them. So I'm not running this to test. There's nothing to test. You see there's no main method, so it's not going to run. But it's always a good idea to make sure you don't generate a lot of code without testing it. In fact, I would even say that normally the way I'm developing this is not ideal because I've written a lot of code without running anything. So I would always recommend that you start having some sort of main method, and that as you build each method or each class, you incorporate that into your test method just to make sure that everything's going okay. It's a little tricky when you're doing things like this with a class hierarchy, and in this case, it's 3 levels deep. So it'd be hard to actually do anything right now because we can't instantiate any of these methods, but we're going to do so soon.